Hello and welcome. This is Cambridge O-Level Physics Paper 1 Multiple Choice. This is May-June 2022 exam. The subject code is 5054 and this is version 2 of this exam. Let's start. First question, it says a force of 3 Newton and a force of 4 Newton acts on an object. What is the maximum possible resultant force of these two forces? So for example, assume that this is an object and two of these forces are acting. For example, 4 Newton is acting this direction, 3 Newton is acting this direction. So the resultant will be 1 Newton. So and if 3 Newton is acting in this direction, the resultant would be somewhere here. This would be around 5 Newtons. And if 3 Newtons is acting in this direction, this will lead to 4 plus 3, 7 Newtons. And if 3 Newton is acting this direction, the resultant would be 5 Newtons in this direction. So we can see that the maximum force can be achieved if both of these vectors are acting in the same direction. So the answer C is the best choice, 7 Newton we have. Next question, it says a length of copper wire is labeled length 0.5 meters and diameter 0.5 millimeters. Which instruments are most suitable to measure accurately the length and diameter of the wire? So for the length, the options are meter rule and calipers, and similarly for diameter, the options are meter rule and micrometer. So if we see these values, 0.5 meters can be easily measured with the help of a meter rule, and 0.5 millimeters can be easily measured with the help of a calipers or a micrometer. So since we do not have micrometer here for measuring the diameter, so we will go with the micrometer. So length, meter rule, diameter will be either calipers or micrometers. So we have only micrometers here. So micrometer on micrometer and meter rule here. So the best answer is B. Next question. It says the graph shows the speed time graph for a parachute who jumps from a plane but does not open his parachute immediately. At which point does he open his parachute? So we can see that from 0, he jumps, the speed increases till the parachutist reaches the terminal velocity. And at point B, suddenly there is a deceleration again, or the speed decreases till it reaches point D, where it again reaches the terminal velocity. So we can see from here that once the parachutist, or as soon as the parachutist opens its parachute, there will be a sudden change in speed. So the answer B is the best choice, because we can see there is a sudden change in speed and the speed decreases. So B would be our best choice in this case. Next question, it says a 60 kilogram passenger enters a stationary lift. The gravitational field strength G is 10 Newton per kg. How much force does the floor of the lift exerts on the passenger when the lift accelerates upward at 2 meters per second square? For example, this is our lift, and our lift is accelerating upwards. So the acceleration is 2 meters per second square. And the person, say this guy is standing here, his weight is acting downward. So weight is mass into gravity. So weight becomes 600 newtons. And similarly, there is a force acting because of acceleration. So this lift is moving upward. So in order to counter this, the force the person will exert on the floor of the lift. So this is the floor of the lift. This is floor. Force will be equal to mass into acceleration. Mass is 60, acceleration is 2. So it comes out to be 120 newtons. So overall force exerted by the person on the floor will be 600 plus 120. This becomes equal to 720 newtons. So answer D will be the best choice we have. Next question, it says the diagram represents the moon in its orbit around the earth. Which arrow represents the direction of the resultant force acting on the moon at the instant shown? So at this point, this is the direction. So the resultant force will be the centripetal, the resultant force will be the centripetal force, and that centripetal force will be acting towards the center of the earth. So A will be the best choice we have. Then question number 6, it says a measuring cylinder containing water is placed on a balance. A stone is placed. A stone is placed into the water. The diagram shows the reading on the balance and on the measuring cylinder. So the question is, what is the density of the stone? So we can see from here that initial mass of water is 55 grams, and after the stone, it is 92.5. So we can find out mass of stone. Mass of stone is 92.5 minus 55, comes out to be 37.5 grams. Similarly, volume of stone. So initial the volume is 20 centimeter cube. Now the volume is 35 centimeter cube. So change in volume, 35 minus 20, 50 centimeter cube. So this is the volume. And we know that density is mass per unit volume. So mass divided by volume. So it comes out to be 37.5 divided by 15. This is equal to 2.5 grams per centimeter cube. So from this, we can say that answer number C is the best choice we have. Next question, it says the diagram shows a uniform solid rectangular block of weight 50 newtons. That is pivoted about point P. The height of the block is 40 centimeter. The base of the block is 8 centimeters wide. Which horizontal force F just makes the block start to rotate about point P? So this is our point P. So we have to basically calculate the moments about this point. So this is point P. This is the distance, and this is the force acting here. Similarly, if we see the mass is, or the weight is acting downward, and the distance of weight acting downward is this, is in this direction. So, and this distance is 8 by 2, 4 centimeter, or half of this length. So if we calculate moments about P, it becomes, so calculate moments about P. So it is sum of clockwise moments is equal to sum of anti-clockwise moments. So we can say that 40 centimeters multiplied by force is equal to 4 centimeters multiplied by weight acting downwards. So the force becomes 4 divided by 40 multiplied by 50. So this 10, and this becomes equal to 5 meters. Yes. So the answer B is the best choice we have. Next question, question number 8. It says the center of mass of a solid rectangular block is at its center. So this is at its center, the center of mass. A heavy weight is available. In which of the arrangement is the center of mass the lowest? So remember, the center of the mass will be lowest when we have when we have a wider base. So we can see that face F is, or area of face Y is more than area of face X. So if our block is resting on face Y, it will have its center of gravity or center of mass much lower to the base. So and if we put a heavy object over it, so what will happen? The center of mass will rise up rather than going down. So we can, and generally students make a mistake that since lower the center of mass, more will be the stability. So they do it the other way around. They consider that putting a heavy weight on this block will make it more stable, but actually it will not make it stable. It will raise the center of mass because a heavy object is lying at a higher level compared to the block itself. So the best answer would be lying on the face Y. So let's see. With face X on the table, no. With face Y on the table, yes. With face X on the table and heavyweight attached centrally on the top of the block, no. With face Y on the table and heavyweight attached on the centrally on the top of the block, no. So answer B will be the best choice we have. Next question. It says the graph shows the extension of a spring depends upon the force applied. Which point is the limit of proportionality? So this is a force to extension. So remember, force is directly proportional to extension, and it is equal to K times X. And this is basically the Hooke's law. So proportionality limit, we can see that till point C, the proportionality limit is observed. So as force is increased more than what it is at point C, the spring comes out of the proportionality limit. So the limit or the maximum edge for proportionality is C. So answer C will be the best choice. So remember, some of the students make mistake, they put D here. So D is not the limit of proportionality because the spring is already outside the limit. So limit of proportionality, it will remain a linear graph between force and extension for that. So next question. Question 10, it says an elastic spring has an unstretched length of 30 centimeters. A load of 6 Newton is hung from the spring and the length of the spring is now 66 centimeters. So for example, we have a spring, and that spring with a hook, you can say it has a length of 30 centimeter. Now you just add some weight to it, and now the length is 66 centimeter and this weight is 6 newtons. So we can, and we know that force is directly proportional to X, and it can be written as F equals to Kx. So the value of K is force per unit. So force is 6 divided by change in length. So the change in length is 66 minus 30. So 1 by 6. And this is value of K. This is newtons per centimeter. So this is the proportionality constant. So we can simply write it as F is equal to 1 by 6 times X. So this is the formula we have. So now if a load of 2 Newton is now hung from the spring, what is the new length? So load is 2 Newtons, 1 by 6 X. So X comes out to be 12 centimeters. So overall length will be actual length 30 plus this extension 12. It comes out to be 42 centimeters. So this is answer C will be the best choice we have. Next question. Question number 11, it says that barometer is an instrument used to measure atmospheric pressure. In one of the barometers, the height of the liquid in the tube is measured. In which of the diagram does the height represents the atmospheric pressure? So remember this this is not the case because atmospheric pressure is here, atmospheric pressure is here, so both the pressures are same. So there should be actually no difference in height. So difference in height will result because of change in pressure at both ends. Similarly, this is again a diagram. It's more of a sort of a capillary reaction. So atmospheric pressure is acting here, atmospheric pressure is acting here. So this height will have technically no correlation with the atmospheric pressure. Similarly, in this example, we have atmospheric pressure acting here, and then there is again air over here, and that is in a way compressed. And so both are values of air. So we can't basically relate the atmospheric pressure or air with respect to this height. So in part D, we have vacuum here and we have atmospheric pressure or air acting here. So this height will give us a relationship between atmospheric pressure and the height. So answer D will be the best choice we have. Then question number 12, it says a manometer contains mercury. Of density 14,000 kilogram per meter cube. The manometer is connected to a gas supply and the difference in height of the mercury levels is 72 millimeter. The atmospheric pressure is 100 kilopascals. The gravitational field strength G is 10 Newton per kg. Says what is the pressure of the gas? So remember, there is an atmospheric pressure, so we call it PA, and this is 100 kilopascals. Okay, and there is this pressure because of this gas, so PG we can call it as PG. And this is this column of mercury. This is because of the pressure of gas. If there is the pressure of both air and gas would be same, this both of these lengths will be the same. Since now pressure of gas is higher than pressure of atmospheric pressure, therefore we have a length more towards rising towards the side where it is open from there. So let's find out what is the you can say pressure exerted by mercury column. So the overall pressure of gas will be equal to PA plus pressure of mercury column. Okay. So this will be basically giving us the value, and this pressure is we can calculate as mgh, or the value of mass into gravity into the height. So we can say that mass is or density, sorry, rho gh. This is not mgh, this is rho gh, that or that the pressure if it is given. So rho is density, kilogram per meter cube, multiplied by gravity 10, multiplied by and this value of 10 is Newton per kg, and this multiplied by height is 72 millimeters. 10 this. So if we multiply it, kilogram, meter goes this, meter square. So overall this becomes 10.08 kilonewtons. So now the overall pressure of gas will become 100 kilonewtons plus 10.08 kilonewtons, and this becomes equal to 110.08 kilonewtons. So if we see this, the choices given, so the answer C will be the best choice we have. Next question says, which device provides a continuous steady energy output for the longest time? So if we say the nuclear reactor, yes, it's a good source for long-term energy supply. Solar panel, no, it will not operate during the night time. 1.5 volt cell, it have a limited time. No. A wind generator, again, this is it relies on the availability of wind, and that is very you can say random in nature, so no. So answer A is the best choice we have. Then question number 14, it says a load is pulled by a rope attached to a motor. The resultant force exerted by the rope on the load is shown in the diagrams. In each diagram, the load moves in the direction of the in the direction of the force shown, and uh, takes 10 seconds to travel 1 meter. In which diagram does the motor work with the greatest power? So remember, work done is force multiplied by the distance traveled in the direction of force, and power is given as work done uh, per unit time. Okay, so we can see from here that force is 12 Newton, and in the same direction it has traveled 1 meter. So the work done is 12 multiplied by 1, and the power is work done divided by time, 10 seconds. So it becomes 1.2, you can say, watts. Similarly, this 8 Newton, it becomes work done as 8 into 1, 8 joules, and power becomes equal to 0.8 watts. Similarly, for this, it becomes 1 watt, and this becomes 0.4 watts of power if you do the same calculation. So from here, we can say that which is motor has, in which diagram the motor work with the greatest power. So answer A will be the best choice we have. Next question, it says electrical energy supplied to kettle is 600 kilojoules. So energy, again, energy is 600 kilojoules. You can also call it as work done, W. Of this, 45 is transferred to the surrounding, 15 is used to heat the casing. So for example, this is the kettle, 45 goes here, 15 goes here, 15, 45 here, 15 here, input is 600. Again, all the units are in kilojoules. Remaining energy, so the remaining energy is 600 minus 45 plus 15, 60. It is 540 kilojoules, the remaining energy. So what is the efficiency? So efficiency is energy, useful energy divided by the actual energy supplied into 100. So this comes out to be 90%. So answer B is the best choice we have. Next question, it says, question number 16, it says, how is the heat energy transferred through vacuum? Uh, is transferred to vacuum. How the heat energy is transferred through vacuum of space from sun to the moon surface. So in space, only energy transfers only because of radiation. There is no conduction, no convection. So answer C is the best choice we have. Next question, it says, question 17, a metal cube contains boiling water. Each vertical face of the cube is painted with a different color on its or has a different texture. So identical thermometers are placed or held at equal distances from each vertical face. Near which face does the thermometer read the greatest temperature? So we have, what options we have? Dull black, dull white, shiny black, shiny white. So remember, white surface is a poor absorber and radiator of heat. Similarly, shiny white surface is even poor absorber and poor radiator of heat. It's a good, only a good reflector of heat. Similarly, dull black surface, good absorber, good radiator of heat. And similarly, shiny black surface, good absorber and good reflector of heat as well. So overall, if we compare between dull black and shiny black, dull black will absorb more energy and as a result radiates more energy. And if a thermometer is placed near a dull black surface compared to a shiny black surface, the dull black surface thermometer will show more or value of temperature or more value of temperature. So answer A will be the most suited or best answer we can have in this situation. The next question. Question 18, it says the liquid column in a liquid glass thermometer is 2 centimeter long at 0 degree centigrade. The column expands by 10 centimeters when heated to 100 degrees centigrade. So expansion or rate of expansion is 10 centimeters for 100 degree C, whereas 1 centimeter for 10 degree rise in temperature. So measuring from P, how long is the liquid at column at 30 degrees centigrade. So for 30 degrees centigrade, we have expansion of 1 centimeter by 10 degree C multiplied by 30 degrees C. So it comes out to be 3 centimeters. And from the tip of the P, measuring from P, so add 2 centimeters to it. So the answer comes out to be 5 centimeters. So answer C is the best choice we have. Next question, question 19. It says liquid in glass thermometer consists of a bulb containing a liquid which expands into a thin capillary tube. The liquid in the thermometer is replaced by the same volume of different liquid that expands more for the same temperature rise. The length of the capillary tube remains the same. So question is, how does the thermometer compare with the old thermometer? So if we have changed the liquid with a liquid that expands more or have more thermal expansion, what will happen? So for example, this liquid for temperature difference T, this liquid goes X, the same liquid will go, for example, this Y distance. And the temperature change, for example, change is 10 degrees. So for 10 degrees, we have more length covered. So actually we have increased the sensitivity of the thermometer. Also, we can say that overall, say with one liquid or liquid X, uh, we can measure, say, from 0 to 100 degrees centigrade. But the same, but if the liquid is changed with the liquid that expands more for same degree rise in temperature, so we may be able to measure, say, from 0 to, say, 50 degrees centigrade. Although our sensitivity has increased, but our measuring range has decreased. So these are the 2 points which are important while comparing these thermometers. So first is greater sensitivity, yes, and greater range, no. It has greater sensitivity, yes, smaller range, yes. Same sensitivity, no. The sensitivity increases for the, if we change the liquid with the liquid that has more expansion or more thermal expansion coefficient. Similarly, it has same sensitivity, no. So answer B is the best choice we have. Next question, it says steam at 110 degree condenses on the surface to form water droplets at 100 degrees centigrade. What happens after the steam comes into contact with the surface? So the molecule slows down, absorbs energy from the surroundings. The molecule slows down, yes, emits energy to the surrounding. It looks good one. So the molecule stays the same. No, the temperature has decreased. So they will slow down not and absorb energy. No, so they do not absorb. They will not absorb energy. They will, the temperature will increase and they will start vibrating more frequently. So this is not the case. So my molecule stays the same speed again and emit energy. So if they emit energy, they slows down. No. So they emit energy and slows down. So if they remember, if they absorb energy, they will move more faster. The vibrations will increase. So that won't be the case. So they slow down and they emit energy to the surrounding. So answer B is the best choice we have. Next question. Question number 21. It says, which list shows the states of matter in order of expansion from smallest to greatest for the same temperature rise? So remember, the gas expands the most and the liquid expands, and the solids expand the least. So from smallest to greatest, it will be solid, then liquid, then gas. So look for this option. So gas, liquid, solid, no. Liquid, solid, gas, no. Solid, gas, liquid, no. Solid, liquid, gas, yes. Answer D is the best choice we have. Then question number 22. It says which row describes the boiling and evaporation of a liquid. So boiling, bubbles form throughout the liquid. Yes. forms throughout the liquid? Yes. Occurs at any temperature? No. The boiling is fixed, or a boiling point is of any liquid is a fixed temperature. So it only happens at that when the overall liquid or that substance reaches that certain value. So no. Then evaporation only occurs at one temperature? No. Evaporation takes place at all the temperatures. Number two, it produces cooling. Yes. Evaporation causes cooling. Yes. Occurs at one temperature. No. Produces cooling. Yes. So the two yes, we have answer B is the best choice. Next question, question number 23. It says the hair dryer is used to blow air across the surface of water in a beaker so that the water evaporates. What increases the rate of evaporation? So the rate of evaporation of water. So for example, this is the beaker we have, and this is the water. So rate of evaporation. So for example, if we decrease the speed from the hair dryer, no, we have to increase the speed so that the molecules at the surface will be swept away and more new molecules from the surface of water will have chance to escape the surface. So we need to increase the speed, not decrease the speed. This is not decreasing the mass of water in the beaker. So rate of evaporation technically doesn't depend on the mass. It is the number of molecules or number of water vapors or molecules that are available on the surface and that have enough energy to escape the surface. No, we can't say that. Then increasing the surface area of water by using a wider beaker. Yes, this will also increase the rate of evaporation. So if you have bigger area, there will be more number of molecules available at the surface, even with the same mass of water, and there will be more evaporation. Then it says increasing the volume of water in the beaker. Again, it will have no effect because the surface area of the water that is or which is available for or the area available for the water molecules to you can say escape the liquid is the same. So this is again not the answer. So eventually answer number C is the best choice we have. Next question, question number 24. It says the diagram shows a ray PQ reflected by the mirror to a parallel mirror Y. The reflected ray along RS is parallel to Q. So RS is parallel to PQ. So mirror X, this is, so which statement is correct? The angle between PQ and QR. This angle is 90 degree. This angle is 45 degrees. Again, this angle is 45 degrees. This angle is 90 degrees. This angle is 45 degrees. This is simple mathematics. Then angle between QR and RS. QR and RS is 90 degrees, not 180. This is 90. PQ, this is 90. Angle of incidence of PQ on the mirror is X is 60 degree. So no, this is 45 degree. The angle of incidence QR on the mirror Y is 45 degree. QR on the mirror Y is 45 degrees. So answer D is the best choice. Next, question number 25. It says an object is viewed through a thin converging lens. The diagram shows two paths of shows the paths of two rays from the top of an object to an eye. How does the image compare with the object? So this is here, so the image will be formed somewhere here. The image is virtual, it is upright, it is larger inside and on the same side of the object. How larger? Yes. Inverted? No. Larger? Yes. Upright? Yes. Smaller? No. Inverted? No. Smaller? No. Upright? Yes. So best answer is B. Next question. Question 26. It says violet and indigo light have the smallest wavelength in the spectrum of light. Which three colors in order of increasing wavelength immediately follow indigo? So remember wave G. So violet, indigo, blue, green, yellow, orange, red. So this is 400 nanometers approximately, and the red is around 700 nanometers. So this is the visible spectrum. spectrum or visible light spectrum, you can say. Visible light spectrum. So violet, indigo, then comes blue, green, yellow. So blue, green, orange, no. Blue, green, yellow, yes. Green, blue, yellow, no. Yellow, green, orange, no. So answer B is the right choice we have. Next question. It says, question 27, a sound wave passes through a substance. The diagram shows position of molecules of the substance at one point of time. So this is the point we are looking for. What is the type of sound wave and what is at X? So sound is a longitudinal wave. All electromagnetic waves are transfer waves, such as light wave, radio waves, microwaves. They are transverse in nature, whereas the longitudinal waves are or sound waves are longitudinal nature. Similarly, we can see that the molecules are compressed in the region X, whereas the molecules are far apart or rarefaction is taking place in the other regions. So we can say that type of wave A is longitudinal and compression is taking place. Answer A is the right answer we have. Next question. Question number 28. It says a man stands between two tall buildings P and Q. He is 50 meters from P and 200 meters from Q. He sounds a horn. He hears the echo from building P, and 1 second later he hears the echo from building Q. What is the speed of the sound? Calculating for this information. So for examples, for first sound to travel back to him, the time, let's say T1, so distance travel is 2 times D divided by speed of sound, that call it B. Similarly, the sound from here goes there, comes back, so distance traveled, so T2 is 2D divided by V, 2D2, if I call it 1, and velocity of sound remains the same. So T1 becomes 100 divided by V, and T2 becomes 400 divided by V. And if I say delta T is 1 second, or the difference between the sound when he hears them is 1 second, so T2, T1 comes, so T2 minus T1, 400 V minus 100 V is equal to 1. So V is equal to 300 meters per second. So answer B is 300 meters per second. For this question, remember, some of the students make mistake that they select 330 meters per second as speed of sound, but always do the calculations. Sometimes there is a trick, so you can just say, oh yeah, speed of loud sound is 330 meters per second, but this is not the case in this numerical problem. So be careful with that. Next question, question 29, which says, what is one of the uses of ultrasound? Cleaning jewelry? Yes. So ultrasound baths are used to clean utensils and jewelry. So this is used. Fluorescence tubes? No, they do not require ultrasound. Similarly, optical fibers, they involve light sources, and the lights are technically transfer waves. There is no sound waves or longitudinal waves involved here. And then sunbeds, again, they are talking about the solar radiation and something like that. So answer A is the right choice we have. Next, question number 30. It says, a positively charged rod is held near an uncharged metal sphere on an insulating stack. What is distribution of the charge sphere? So if positive is here, it will attract negative charges here. And this in a way move the positive charges on the left side. So something like this would be, or a similar diagram would be the answer. So A, no, B, no, C, yes. So answer C is the right choice. So it's not D, because positive will attract the negative charges. So it won't be like this. So D, no, B, no, A, no. So answer is C. Next question. Question 31, it says two metal spheres are mounted on insulating stands. Sphere X is initially uncharged and sphere Y is initially positively charged. A metal rod held by insulating handle is placed in contact with X and Y as shown. What are the charges on X and Y after the rod is placed in contact with them? So Y is positively charged, so positively charged eventually makes this as positively charged as well. So charge positive charge transfers because of this wire. So half of it is over here, half of the it remains on Y. So as if here X will be positively charged and Y will be positively charged. So answer from here, A is the best choice we get. Next question. Question number 32, it says diagram shows a simple electric circuit. Which row describes the charge on an electron? So charge on an electron is negative. Electron is a negatively charged particle, and the direction of electron flow from always flow from negative terminal to positive terminal. So remember this. So from the negative terminal to the positive terminal, from X to Y. From Y to X, from Y to X. So from Y to X in the circuit. So answer B is the right choice we get. And remember, electronic charge flows from negative to positive, whereas conventional charge or positive charge flows from positive to negative in a circuit. Next question. Question 33, it says a charge of uh, charge of 0.4 coulombs passes through a resistor in 1 second. In 2 seconds, energy of 20 joules of thermal energy is produced in the resistor. What is the potential difference across the resistor? So remember, power is given as energy produced or work done per unit time. So work done is 20 joules and time is this. So 2 seconds, so power is 10 watts. Similarly, we know that charge equals to current times time. So it becomes we don't know, 1 second, and this is equal to Q is 0.4 coulombs. So I becomes equal to 0.4 amperes. So we know that power is equal to V times voltage times current. So we have current value with us, so 0.4 times V, and we divide it by power, or that is equal to 10 volts. So our value of voltage becomes 10 divided by 0.4. This is equal to answer C, 0.2 or 25 volts. Okay, so this is how you solve this question. Next question, question number 34. Question number 34 says the diagram shows a simple electric circuit. Which meter measures the current in the resistance R2? So here we can see that we are given a circuit and there are few meters. When I'm saying meters, we can see that there are ammeters. The ammeter symbol is given as A inside a circle, and there are voltmeters that are given as V inside a circle. So remember, ammeter is used to measure current and voltmeter is used to measure voltage. So wherever there is a voltmeter, that is not used. So answer B is not the choice. Current in the resistance R2, we need to measure the resistance R2. So remember, whenever we are using ammeter, we have to place the ammeter in series. For voltmeter voltage, we have to use this in parallel. So this current A, this ammeter A measures current in the complete circuit. So it will give you the value of current flowing in the complete circuit. Similarly, the A and C will give you the same values as the current that is flowing I in this whole circuit. So when it comes to this, so some current I1, it divides into two. I1, say I call it I1, I call it as I2. So I need to find I2. So I2 will be given by this ammeter that is in series with that current. Or so this will be answer D will be the best choice we have here. Next question, question 35. It says When the flash on a camera is used, a charge of 1.5 coulomb flows. Remember, charge 1.5 coulomb, time is 0.003 seconds. Through the flash lamp, the average voltage across the flash lamp is, or voltage is 3600 volts. What is the electrical energy supplied by the flash lamp and the average power supplied? Okay, so let's first of all calculate the current. So Q equals to IT. Q is 1.5 divided by 0.003. This will give me the value of current. And for power, we know that power is equal to VI. V is 3600 multiplied by 1.5 divided by 0.003. So if we do this analysis, what comes with us is 1.8 into 10 to power 6 watts. So only option this suits. So this is not an option, this is not an option, this is not. So we can easily say that answer D is the right option, but also always good to calculate the energy. So energy, remember, we have seen the power formula for power earlier, is work done or energy per unit time. So energy we have to calculate, and this is equal to power multiplied by time. So 1.8 into 10 to power 6 multiplied by time is 0.003. So this comes out to be 5400 joules. So this is the right value. So answer D is the best choice we have. Then question number 36. It says the diagram shows an electrical circuit which lamps light when switch S1 is closed and S2 is open. So when you close switch S1, the circuit will look like this. So this will be the path of current in the system. So if the current is passing through L1 and L2, so only L1 and L2 will glow. So remember, the current will not pass through this branch because S2 is open. So open circuit will not result in any current flow. So no current flows through this. So only L1 and L2 will light. So L1 and L2 on. Answer C is the best choice we have. Next question, question 37. It says the diagram shows a hair dryer. First, so which statement explains why the hair dryer does not need an earth wire? So number one, it has a live wire. So what? So live wire, I mean, for protection purposes in equipment, we need an earth wire, irrespective. It has a live wire. It has a neutral wire, yes. So we also use earth wire with neutral wires. For example, in power transmission lines or distribution lines or overhead transmission or overhead distribution lines, we have a earth wire, or I mean, even for our domestic purposes, we have an earth wire. It has double insulation, yes. So double insulations. So earth wire basically protects us from electrical shocks. So that is one of the advantages of that. So it has double insulation, yes. This is one of the reasons why uh, we don't need an earth wire, because the risk of electric shock is minimalistic in this case. And then the cable is insulated, yes, the cable is insulated, but it has double insulation. That is the best answer. So answer C is the best choice we have. Then question 38, it says a left hand can be used to determine the direction of force when a current carrying conductor is perpendicular to the magnetic field. So remember, this is the law for motor or left hand frame includes which quantities are represented by the direction of P, Q, and R. For left hand rule, remember that the middle finger or R represents the value of current, and Q represents the value of magnetic field. And P represents the force direction. Okay, so let's see which is there. So P is current, no, field, no, force, yes, force, yes. Q, magnetic field, yes, force, no, current, no, field, yes. Then R is current, no, force, no, current, yes, field, no, current, yes. All three reds D. Answer D is our best choice in this case. Next question, question 39. It says that the magnet is moved into a coil of wire as shown. There is a small positive reading on the sensitive ammeter. which change must increase the size of the reading? So remember, this magnet is moving towards this coil. So as it moves, there is a change in magnetic flux, and that change in magnetic flux results in production of current through this coil. So the more or the faster will be the range of change of magnetic flux, the faster and the more will the value of current. More the number of turns in this coil, more be the flux linkages, more will be the value of current or the size of readings at A. So say, let's see what are the options. So moving the opposite pole of the coil, I mean, it doesn't affect, it will just simply change the direction of the current. It will not increase the size or magnitude of the reading. So no. Pulling the magnet out of the coil, again, if we are moving in one direction, if we are going to pull it out in the other direction, the direction of the current will change, but not the magnitude or the size of the current. So pushing the magnet faster, yes, this will increase the rate of change of flux linkages across the coil. So yes, it will definitely increase the rate. So unwinding some of the turns, so decreasing the number of turns will result in decrease in value of the reading or the magnitude of the current. So eventually we can say that answer C is the best choice we have. Next, for question 40, and this is the last question for this exam. So it says electrical power is transmitted by cables over long distances at very high voltages. So what are the effects of using high voltage transmission system? So remember, power, we are transmitting power from one side to another. So for if we have to transmit power, so power is equal to VI, that is constant. So at high voltage, so power, and this is a constant value in transmission lines. So if I increase the value of voltage, what happens is my value of current decreases to keep this power value constant. Okay. So if my value of current decreases, so my I square R losses will decrease because the value of I decreases. And these are actually the power loss in the cable. So this is power loss. So power loss of the cable decreases. So high, no, high, no, low, yes, no, yes. Then again, as we know, we are transmitting at high voltages. If we make the voltage of the transmission levels high, our value of current decreases, and that decreases I square R losses, and actually the value of current also decreases. So current is low, current is low. So 2 ticks, answer D is the best choice we have. So this is all from this exam, and I hope you have learned something from this video. If you learned something, do subscribe and like my channel. And all those who are giving exams and preparing for them, I wish you best of luck. And if you have any questions, please feel free to ask them in the chat. I'm looking forward to that. Best of luck and take care. Bye bye.